Hi everyone, this is the promised video of the lab experiment that I wanted to show you. This is experiment 6, part 1, the common-emitter amplifier. So as you can see here, we have the swamped amplifier, common-emitter amplifier here. And today I'm going to go step by step and show you how you should put this circuit together. So the first thing we need to grab is the transistor, the 2N3904 transistor. The equivalent of this transistor in your kit is 2N4124. So first of all, we have to figure out how we should put this transistor in the circuit. So a transistor has 3 terminals: base, collector, emitter. And then it is very important that we put these 3 terminals in 3 different points on breadboard. On a breadboard, we have 4 actually regions. One region is this one region is this one, the third region, and the fourth region. On the first and the fourth region, each row is connected together. So all of these points on row that is shown with plus are connected together. So if you put 2 different components here, then that means that they are connected together like this node that you see. The same thing for the blue one. The blue one is connected to all the points on the blue line are connected together, but they are separate from the red nodes here. Now on region 2 and 3, it is the columns that are connected together. So this one, this column, all of them are connected together and they are different from each other. The same thing here, but these columns are separate from these columns. They are just connected together. On the fourth region, again, we have the rows connecting together and they are different from the rows here. Unless you connect them through a wire, they are different from each other. Okay, so for an NPN transistor, what we want to do first is to look at the circuit, look at the symbol here, and figure out how we should put the transistor in the circuit. So for NPN, if you match this curved side to the curved side of the symbol, as you can see this almost curved side here, then you can just follow everything from the paper and just implement it on breadboard easily. And that way, if you match it this way, then the top leg is going to be collector, the middle leg is going to be the base, the third leg is going to be the emitter. So again, it becomes very easy to just look at the schematic here and then do it on the board. So I'm going to do the same thing. Remember that since we want the 3 terminals to be 3 different points, we should never put the 3 legs in the same column here, right? If you put them in the same column, that means, as I mentioned earlier in this video, they'll be connected together. So this is a no-no. But if we put them in different columns like this, in 3 different columns like this, then each point is going to be separate from the other. Okay, so we put the transistor. Now we can just follow the terminals and see what should be connected to the terminals and complete the circuit. Since it's your preference, I'm going to start with the base. So here at the base, we have 2 resistors and a capacitor going out. So I'm going to start from the top, from R1, and then complete this. So R1 is 10K. So I grab a 10K from the kit, and then I look at it. It shows that R1, one of the legs is connected to the base, one of the legs is connected to VCC. Okay, so starting from the point that is connected to the base, I'm going to connect one leg to the base. But how do I do that? I just make sure that it's in the same column here as the base. So any of these points would mean that I just basically connected this leg of the transistor to the middle leg of the this leg of the resistor, sorry, to the middle leg of the transistor. So I'll just go ahead and put these two in the same column. VCC is just something that I'm going to take care of it later, but I just make sure that this guy sits right up there in somewhere different than the collector and the emitter. Okay, now we have, we took care of R1, now we have R2, the 4.7. So this is the 4.7K. Again, I see that 4.7, one leg is connected to the base. So I'll go from the base. Again, you see all of these are in the same column because I want them to meet at the same point. Then I have it to the ground. Here, a ground is very important in the circuit because, as you can see, it gets repeated multiple times. So in order to make your circuit neat and tidy, what you can do is to just allocate one of these rows here to the ground, so that if you need to use the ground later, you can just use any of these nodes and connect components to it. So I just say that the blue line on this region is going to be the ground. So R2, I went from the base to the ground. Okay, we're done here. Now next, connected to the base, still we have a capacitor. A capacitor looks like this. Unlike a resistor, it has two different legs. You can see one of them is straight on the symbol, the other one is curved. The straight one is the positive polarization, the curved one is the negative one. We have the same thing on the component. We have one leg that is longer than the other, and if you look on the capacitor, you see that here we have negative sign pointing to this leg here, which means this shorter leg is going to be negative. So if we match it to the circuit, it shows that here they want us to connect the positive leg of the capacitor to the base with the negative side to something from the signal generator. This is a power supply, an AC signal from the signal generator. Okay, so I'll do that. I'll connect the positive side, positive leg, sorry, I'm going to show it this way, positive leg to the base. Again, you see all of these are connected to the same column, to somewhere to the signal. So since I don't want to stretch this too much, I'll just put it somewhere like here, and I make sure that later I connect this leg to the input signal here. Okay, so R1, R2, C, we are done with the base. Everything that was supposed to be connected to the base is done. Now we can move on to any of the collector or emitter. I'll just go to the collector because we have less to worry about. Okay, now for the collector. Again, this is I'm going to show you here. This is the column that represents the collector, number 55 here, you see, 55. So here I have 1 kilo ohm RC connected to the collector from one leg, and the other one is VCC. So I connect this one to the collector, the other one to VCC. If you remember, we previously had R1 to VCC, and we said this is the point that VCC is going to happen. So I'm going to make sure that this leg also sits here in the same column as R1, because now basically these 2 points are connected together as they should be on the circuit schematic here. Okay, RC is done. Now we have something else connected to the collector, another 1 microfarad capacitor. Now you can guess that again the positive side, the straight line, the positive side has to be connected to the collector. The negative side, the shorter leg, is supposed to go to RL. So let's do that. Let's go, I hope, I'm gonna put this here. And now I'm going to connect the positive side to the collector, which is number 55. You can see it. It's gonna get busy here, so you just have to make sure that this leg, this capacitor leg, sits on number 55 so that it would be connected to the collector. Then we put this again somewhere else, anywhere except this column that this guy is sitting, this capacitor is sitting, because we want to make sure that it gets connected to VS. Now the negative leg, which we are here right now, the negative leg is connected to a 10K resistor. This 10K, again, I'm going to grab a 10K here. Make sure that this 10K goes from this capacitor, again, the same column, to the ground. Okay, now I have the ground. And remember that I assigned this blue line here to the ground. So I can just easily connect it to the ground. And since all of these are connected together, all of these nodes, then I have them, if I connect the ground from the power supply to one of these, it's going to be connected to all of them. Okay. So I'm going to make this a little bit nicer here. Okay, then just give you a closer look. Number 55, we have the 1K resistor from RC. We have the capacitor, and that's it. So we are done with everything at the collector as well. Now let's go to emitter. Emitter, we have 100 ohm. Let me just check which one is 100 ohm. I think it's this one, 100 ohm. Going from the emitter, which means the third leg here, to somewhere, this point. So I'm going to connect it to emitter, then put it somewhere here. Okay, again, the same column as emitter because we want to connect it to the emitter. Now we go from, we have the 330 ohm going from this leg of the resistor, 100 ohm, to the ground. So this is the leg we ended up, right? Then we moved from emitter to this leg, to this point, and then we make sure that we connect the 330 ohm from this point to the ground. We come here. You see how easy it becomes when you assign one line to the ground? Then every component, whenever that they're supposed to be connected to the ground, you can just bring them here, and you don't have to like squeeze things in the circuit. So we're done with the 330 ohm. We have a 47 microfarad. I didn't have a 47 microfarad. I'm just using another capacitor, but it's the same thing. Again, we make sure that the positive leg is connected between the 100 ohm and 330 ohm. So this is important. This is where most of the problem happens. Now you have to find out where is this point on your circuit. This is where these two are connected. Let's look at it. This is emitter. So no, we don't want this point. We want after the 100 ohm, which is right here. You see, the 300 and the 100 are meeting each other. So if I move this guy up here a little bit, I go from, it shows the positive leg, the longer leg goes here. So I'm going to connect it right here. then the negative leg that you can see here, the negative leg is supposed to go to the ground. I'll stretch it, I'll bring it to this ground. Okay, it's a bit challenging, but okay. So you see, now this is done. Good. So we are done with all the components. Now what is left is connecting VCC and VS and the ground here. Obviously, I don't have lab equipment at home. What I'm going to do is show you with cables. So let's assume that I connect these two legs of the cables, one of them to the ground, one of them to the positive side of the VCC. So let's go here. Now, this represents the ground. Okay, so I'll take it out of the video so you can see the rest of it. Now this is the ground. Where is the ground going? We said this point is all the ground is going. So I'm going to connect it right here. And since this is connected to all of these, I don't need to worry about them. They're already grounded. Now the positive side. Let's take it out of the video. Now the positive side, VS, is supposed to go where these two guys are meeting each other. If you remember, good. You just go ahead, connect it here. If you don't remember where you assigned it, you can just find it again by following this point on your circuit, which is right here. So I'm going to connect it right here. Okay, good. So this is from VCC. As I said, you make sure that you connect these two cables to the power supply and you turn it on. Now let's go with VS. This is something else I see people make mistake, is that for VS, they just, I don't know, maybe it's a bit confusing, but like any other two-legged component, you have one leg connected to this 1 micro capacitor, microfarad capacitor, one leg to the ground. So if I grab, let me just grab one cable that I can use to connect it to the signal generator. So usually this is the kind of cable you can connect to the signal generator. One side is here, the other side looks like this. So let's just assume that I connected this to the output channel of the signal generator. Now I have two legs. The black one shows the ground. So I connect it to the ground because it is supposed to be to the ground. So I'll connect this to the ground. Any of these components, again, they're already grounded, so it doesn't matter. Now the positive one, this second leg here, is supposed to go to the 1 microfarad capacitor. It's right here, because I left it before. It goes from the base to this one. So something that you can check easily is that you should never, never, ever have any component leg not connected to anything. So I quickly made a guess that this is the 1 microfarad capacitor that I should connect this to it, and not this one, because I already see that this one is connected to the resistor and goes to the ground. It is this one that is not connected to anything. So it was obviously meant to be connected to here. If you don't remember, just follow the schematic. It says it is connected to the capacitor that goes to the base. Should be, so you have two capacitors here and to the capacitor that goes to the base. So it must be this one. Done. So this is the circuit you should put together. Now, for example, let's say you want to do measurement. I'm just going to show you table 6-2 shows VB. Measure VB here. VB. whenever we have one letter at the for the voltage, again I grab two cables, connect them to the digital multimeter. The black one goes to the ground, so I'll connect it to the ground here, doesn't matter which component. Now where should I connect the red one? The red one, obviously one side goes to the digital multimeter. Now if I want to measure VB, voltage at the base, I go from the base, which is right here, you see the middle leg here, from the base, doesn't matter which component, all of these are connected together. All of doesn't matter which component, I mean from these three, because all of them are connected together. Now this leg, the black one, I said it goes to the ground because whenever you have one letter, it means from that point to the ground. Nothing is here. Nothing means 0. 0 means ground. So here, from base to the ground. If you want to calculate emitter voltage, VE, that means again from emitter, so grab this one, to the ground. Leave that one at the ground and just go to the emitter right here. If you want to calculate VCE, here, C stands for collector, E for emitter. So you go from collector, right here, the top leg, to the emitter, right here. And then you calculate that. Okay, so this is for lab 6 part 1. I'm going to do another video on lab 6 part 2. And I hope you I hope that this was helpful. Try to do the same thing if this is the final look of the circuit. And it doesn't have to look like this as long as you follow the fundamental principles that columns are connected, these columns are connected together, and you have all the connections right. Doesn't matter. This is just an example.